I'm going to describe an interactive simulation that models the behavior when we feed into a distillation column, either liquid or vapor or a mixture, and we demonstrate how that feed distributes between the liquid that's flowing down in the column and the vapor that's flowing up. So in this simulation, a wider line for example, vapor, wider here than here means there's more vapor because we've added some from the feed. The one variable is the quality with this slider, and the way quality is defined here is if quality is less than 0, that means we have a superheated vapor, and if it's exactly 0, then we have a vapor right at the dew point. If it's 1, then we have a liquid at the bubble point, and between 0 and 1 means we have a liquid vapor mixture as we're showing here. So partially vaporized means we have a liquid vapor mixture. Greater than 1, subcooled liquid, it's cooled below its bubble point. So what we want to do is now look at this simulation, observe the behaviors, we change the quality. So here's the interactive simulation. We're feeding a vapor at its dew point, and you can see in the simulation all of the flow of vapor adds to the upward flowing vapor. If we were now to decrease the quality, we have a superheated vapor. All the feed vapor indeed still goes into the upflowing vapor in the distillation column. In addition, some of the liquid that's flowing down is vaporized and is added to that vapor flow. If on the other hand we go to a partially vaporized, so the quality between 0 and 1, in this case 0.5, then you can see some of the feed goes into liquid phase and some goes into vapor phase. Keep increasing the quality to 1. At the bubble point, all of the feed goes into liquid phase. If we now have a super cold liquid, all the liquid fed goes into vapor phase, and some of the vapor, upflowing vapor in the column, is also condensed and added to the liquid phase. So this just helps you hopefully to visualize the behavior as we have a feed going to a stage of a distillation column.